All right, we're asked to find the relative extrema. This is kind of continued um, in this section here. We're going to work a couple problems, and then we're going to get into the second part of this, and that's finding concavity. But just to kind of refresh in your memory here, the first thing we want to do here when asked to find the relative extrema is we want to take the derivative. So that should be easy enough at this point. So f prime of x is equal to 2x. And then what we're going to do is set equal to 0 and solve for x. And therefore x equals 0. Right, dividing both sides by 2 or multiplying through half. Okay, well that's our critical number. And remember, critical numbers are numbers that we can plug back into the original function and get a real number out. And so I'm going to skip a number line here. We're going to plot 0 on our number line. And then we're going to choose some critical numbers. I'm sorry, some test points. We're going to choose some test points. So you can pick any number to the left of 0 and any number to the right of 0. And I'm not sure why I chose 2. We could have chosen 2, but how about I just pick 1? 1's a good number. All right, the next thing you want to do is take this -1 and plug it into the derivative. And what we're concerned about is if our value is positive or negative. So I put -1 in, and 2 times -1 is -2. Therefore, I put a little minus sign right here, indicating that the slope of the tangent line at when x is equal to -1 is negative, and that means that any number that you plug in to the left of 0 into the derivative is also going to be negative, and I'm going to indicate that by a line with negative slope. Then we take 1, plug it into the derivative, and we get 2 out, and that's a positive number. So that means that the function is increasing. Now, as you can see here, our graph is going to be decreasing up to 0 and then increasing. Therefore, there's a minimum at x equals 0. And so what we want to do here is actually find the point on the graph. You take 0, you plug it back into the original f of x, and 0 squared is 0 plus 1, and you get 1. So at the point 0, 1, this is a minimum. And are there any maximums? And the answer to that is obviously no, just a minimum.